Hello. Hi, I'm Ben Lorica. I'm your host for this panel of luminaries. And just very quickly, we have Ayal Yogev, CEO and co-founder of Anjuna. Mark, who gave an excellent talk this morning, CTO of Azure. Aaron, similarly, great talk, CEO of Opaque Systems. And Dave Reber, CSO and Head of Product Security at NVIDIA. So let me jump in. I guess let's start with use cases. Two quick questions. So what are the most common use cases that you've seen? And take a step back and tell me your favorite use case so far for confidential computing. Let's start with you.
Yeah, awesome. Thanks, Ben. Great to be here. I think that the use case that we're seeing, if I have to kind of give a high-level title, is enablement. I think the best security solutions were always enablers. They gave you the trust and the confidence to do something that you couldn't do before, and confidential computing is that next big enabler. And the two top use cases that we're seeing, one is the ability to take sensitive data and move it to environments where you don't necessarily, you don't own, like the cloud. So moving sensitive data or workloads to the cloud is one use case that we're seeing. And the second one that is dominating on this R pipeline, this is what we're seeing most of, is confidential AI. So again, companies, I think one of the presenters showed, data is the new oil, data is the new bacon. That's what has been going on for the last 20 years. But a lot of these companies have collected the data and really weren't able to fully take advantage of what that means. Now with AI, they finally see, okay, there is a way to go do that. But in many cases, that data is very sensitive. And if that's the case, they can really leverage it in AI the way they want to, and confidential computing is becoming the enabler for that.
So what's your favorite use case?
Well, I kind of actually did my spoilers in the talk, but I think multi-party computation is one, and I gave a few examples of that. The RBC example I gave, which I think is a canonical demonstration of what's going to happen to advertising with confidential computing, is one of my favorite use cases just because it's so representative, and because it's not currently regulated, but there's privacy laws that are moving in this direction, I think will be accelerated with confidential computing. And the other one, of course, is confidential AI, which everybody's been talking about. And the use case I highlighted too, that's I think the most relevant and the one that's going to accelerate the fastest is confidential inference, and confidential inference with RAG on top of it, which I demonstrated. Both of those, I think, we're at the takeoff point. And so it's this combination of hardware is there, software is there, and AI is there that's going to lead to this acceleration with those kinds of use cases.
Sure. From Opaque's perspective, we've seen use cases around generative AI like everybody has. Karthik from Accenture was talking about a performance car manufacturer who's using actually Opaque to provide a confidential control plane for data governance policies around user and group enlistments. We also have ServiceNow speaking at the conference around a very similar use case. But I'll take it into a different, less popular topic around analytics. We see a lot of companies that are doing confidential analytics around HR trend or sales commission trends, where they're taking data from Workday, combining it with data from a data source like Snowflake or Databricks, as well as another system of record to identify trends around employee attrition or compensation. I think that's a really interesting one because it's such a massive market opportunity that they couldn't access previously, taking customer or employee voice surveys and combining it with Workday data, et cetera. So there's some of the use cases that we're seeing that are pretty exciting.
This may surprise you, but I'm going to say AI. Traditionally, I say confidential computing has been an enabling app to build trust in cloud computing and help enable those movements of things that we never were able to move before. But AI truly is, I think, the killer app. Right, this era in AI is going to allow us as a society to solve problems we only dreamed of solving, whether it be in medical research, whether it be in cyber defense, my favorite topic, but any of those kind of areas. But I think to your point, Mark, it really gets to the ability for people to collaborate on data that now is the new definition of intellectual property for those companies. But by combining those data in ways that we're able to solve bigger world societal problems that we've never been able to do before, but still protect the new IP that these companies have.
So speaking of AI, I joke a lot that last year the word of the year was Copilot. And this year, it seems like developers are super excited about agents. So agents and multimodal AI. So anyone who wants to comment on confidential computing in the context of, so agents, to distinguish them from copilots, maybe have more autonomy than the traditional copilot application. I guess they're mainly aspirational, I would say, right now. I mean, there are some good examples. But so confidential computing in the context of multimodality and agents. And anyone who wants to weigh in, feel free to do so. So I guess we're looking at you, Mark.
Well, you said it last year, the word of the year was copilot. I think it's still this.
Yeah, it is. But agents have definitely grabbed some mind share.
So people are talking about agentic systems now. But I think I mentioned too the speech transcription case, which is a case where you want confidentiality preserved end to end for the data, both the speech coming in and the text coming back out. When it comes to agentic systems, I think we're still at the very early stages of understanding what those things, how to construct those kinds of systems, and mapping that onto the limitations that we're finding in LLMs, because there are limitations. The hallucination is a significant limitation. But I'll say that as we figure this out and have the appropriate guardrails in place to take advantage of LLMs, but still make them so that they're providing true value and not misleading us with hallucinations, is confidential computing can create this boundary, and I refer to that as a confidential trust boundary, where data is moving through a collection of systems and protected the whole way through those systems, because those systems are establishing trust, and this is code-based trust with each other, which I think is what we're starting to see being built, is not just I give the data to an enclave and it processes it, but I give it to a system that is built of enclaves that are establishing trust with each other based on their code identities. And that is obviously going to be necessary as we've got agentic AI systems that are passing data between each other.
So I'll add on what Mark's saying, which is he was making a sincere joke that was based in reality about it's still Copilot, but as you're talking about multimodal, the various content types that are being used in multimodal are increasingly super sensitive data. So I would say it's still Copilot, but moving it into production, because so much of what has been adopted is either more pet projects or ones that are squandering or like paused in pilot because they can't move into production because they have the inability to have a chain of custody around the data that's used in multimodal. Mark's solving that problem at Azure for sure.
And also to build on top of what Mark said, confidential computing is not just the protection of memory. It's obviously a big part of it, but I think the most important and the most powerful part is the attestation piece. And what attestation essentially gives us is an identity. It gives us an identity to workloads and applications. And similar to how we had to transition security of identity and how we use identity for users and create policies around that, what an HR person can see versus what a finance person can see. We're going to have that same thing for workloads and applications and for AI. And that's exactly where confidential computing can help bridge that gap.
Yeah, and one thing I'd add, confidential computing is one of the very first full stack security problems. It requires end-to-end integration. Traditionally, your security products, like you could work at individualized layers and mitigate your risks, but is now allowing us to actually look and measure, to your point with attestation, the entire full stack with the problem. Now, as we look at how do we democratize AI across the world so everybody has access, as we get the confidential computing, the services up and running that are just simple and easy to use, it will allow more people access to AI, but even on the most confidential data sets. Because to your point, it's going to require all of us working together in what we used to call microservices, right? Now we're going to call agents, all working together and actually to derive that final output for utility in those applications.
So, speaking of retrieval augmented generation, so I think one of the things that people don't appreciate is there's a lot of knobs to turn when you're building a RAG system and you really want to tune it. So you have to run these experiments at scale, computationally intensive. So are there any specific challenges that some of your users have come to you about, hey, I want to build a RAG system from scratch, right? So and I have to turn all these knobs, like, how do I chunk the data? What's the embedding model, right? So are there any specific challenges that they come to you that only confidential computing can address in this context?
Well, one of the things that I've seen on the Gen AI side is when they build their RAG models, they're often unable to provide data governance policies at the data source level. So let's say that you have multiple types of groups of users. All of the data gets put through a RAG model, enriches a prompt, and there needs to be an additional layer that we're seeing companies come to Opaque for, like the performance car manufacturer was a good example of that, where they can provide rules around, oh, that's a customer, that's a dealer in this region, that's a supplier, that's a staff member. And they're applying those governance policies without having to re-architect the data model, which would be tens of millions of dollars in 5+ years. So I know I'm operating at a higher level. These guys probably can get a little deeper into the weeds.
I mean, one of the challenges with AI is just, or what we try to or look at is just start using it because there's all of these operational aspects, right? So he's talking just, yes, there's the tuning aspect, but how do you do that at enterprise scale? How do you keep it going? All of the derivative systems that you have to integrate with to keep going with it. When we look at confidential computing, it now allows the conversation to shift and say, hey, yes, you can put your most sensitive data into this model because it's in this enclave and you're going to trust this thing versus putting it out there and not knowing. Because there's some companies that are fearful of what if I ingest all of my data? What happens to all of my data? What do I do? Is it in this country? It is in that country. This finally gives us some of those protection technologies at a scale that we didn't have before.
And I think the others have covered the RAG and some of the things that confidential computing can do with RAG. I think what Dave just touched on, which is data sovereignty. I've always had the vision, and this isn't directly related to RAG other than the way Dave connected it, which is, can confidential computing make it so that in-country means it's in confidential computing? In other words, somebody that has regulations that say this data has to stay in country, which if you think about it, that's kind of a very weak model around, basically saying and hoping that laws are what control access to the data, but instead having the code and the hardware be what gates access to the data. And if you're trusting that, why does it need to be in country? I'd love to see the point where that confidential computing realizes that part of the story, where we've kind of broken the geographic boundary and made it a code and hardware boundary.
So I'm seeing this in the field right now. We have the European Union as a client, and they're taking data from EU member countries, analyzing it to detect emerging cyber threats around ransomware attacks, malware attacks. And interestingly, that's how they're treating it. Now, it's running in the EU, but each of the member countries are connecting their data sources and then processing in one location in the EU. So in this scenario, it's actually being treated in the TEs as sovereign.
Yeah, and the challenges that we're seeing, so I agree that the use cases that were discussed in data sovereignty, I think is going to be definitely a big one. The challenge that we're sometimes seeing is if you kind of look at how the stack of confidential computing is built, you have the hardware vendors that have built the hardware itself to enable it. You have the cloud vendors that have created, sort of open it up as part of the cloud, and then you have people running to run it on-prem for a bunch of use cases. And that poses a challenge. So customers that have, or people that have already convinced on the value of confidential computing, they know that this is something that they can leverage for these use cases, run into an issue where they have to build on top of a lot of different platforms and potentially a lot of different clouds and also on-prem. And that's a challenge that, we typically see where we can kind of come in and help on running this, making this really ubiquitous across any environment, any hardware, any place you want to run this on, to leverage the use cases that everybody talked about.
All right, so let's switch to trends, and we'll start with Dave. So what trends are you seeing beyond just saying AI?
AI.
So let's drill down and be more specific. So what trends in confidential computing do you think this audience should be aware of?
It does get back to those, I think, the joint collaboration use cases. I don't think I've ever seen so many competitors willing to want to start talking and working with each other, but using their most sensitive IP. So yes, AI, but AI is actually redefining what is IP for many of these companies. Where is the value? Is now the data set? It used to be the software code. So what is the value of each of those those competitors, and how do they now collaborate and work together to solve problems that we only can solve together. One example that I slightly touched on, but is from a cyber defense perspective, right? It is a collective defense problem. And cyber traditionally has been a data problem, where Azure has data on their data centers. I have data on my data centers. Google has data about their data centers. But to actually find the most advanced adversaries, we got to find a way to just pump all that together. And it is a collective defense because all of us are in this together, because it is a full platform play now, and is a full platform requirement now that we're only as strong as our weakest link. So the trend I would summarize as that collaboration on a new type of IP in this era of AI.
So I'll pick a different one, even though that's a great one. I'll pick a different one. The weaponization of AI is giving Opaque, unfortunately, a real boom to our business. And specifically what I mean, and I touched on this in the keynote, is hackers are far more efficient than ever using Gen AI. That's pretty obvious. The one that's less obvious is, as businesses operationalize their data, they're using a variety of data obfuscation techniques that are all now irrelevant. Taking mass data and putting it into ChatGPT with some publicly available data within a matter of milliseconds will unmask that data set. It's remarkably easy to do. So in the event that somebody intercepts your data that you've obfuscated, it is irrelevant that you wasted the data engineering cycles to even bother doing that. So it creates a real urgency for companies to adopt processing encrypted data. It's been a real boom to our business.
So I'll go to a different layer because people are talking about AI and RAG and multi-party computation, and what I'll talk about is the trend that I see in hardware. And that trend, if you take a look, has been going on for several years, but it's accelerating now, and that is that every hardware manufacturer now is looking at confidential computing. We just had ARM announce the confidential computing architecture as part of their latest line of the ARM architecture. And that's an example of, we didn't have that in ARM just a year ago. Now we've got it. We've got Intel and AMD with confidential virtual machines. We've got NVIDIA with confidential GPUs, and we're going to see confidential computing with TDISP connect all these hardware devices together in a confidential boundary. You're also going to see it start to go into other hardware devices that also support confidentiality, whether that's an HSM or an SSD. All of those will become part of the story.
So, Mark, are you seeing accompanying software tools to make this hardware even more accessible to developers who may not be at this conference this year, but maybe expand the number of people who are...
So, sorry, I'm not sure I understand the question.
Just kind of the tools behind the hardware. I mean, are there...
the tools to make the hardware, or the tools to...
The tools to make to get more developers interested in the hardware.
And developers, sorry, just to make sure I understand, developers interested in using the hardware?
Using the hardware.
Well, I think that's where the finished services on top come. Like, ideally, developers don't need to worry about the hardware and the attestations. And, I showed the RAG demo this morning that showed web pages, with the attestation reports. Developers don't need to see that. Developers need to see, is it trusted or untrusted? I've set a policy, and that policy actually supports the upgrade of the software too, because I don't want to have to go and reset the policy every time. This is the job of the systems on top, to make it so developers are just interacting with systems as if they were non-confidential, but getting all the benefits of confidentiality.
Yeah, so just to build on that, I 100% agree. And we've seen this over and over again. Every time there's a new hardware architecture, you need a software stack on top of it to enable it and make it easy to use and make it ubiquitous across different hardware solutions. In some extent, that's how Microsoft started, right? The original operating system was a software stack to make it easy to use, the 8086 by Intel. We've seen it with CUDA and NVIDIA, the software stack that makes it easy to use. And I guess the example I love to use is VMware and virtualization, right? VMware didn't invent virtualization. They built a software stack on top of what the hardware provided to make it easy to use virtualization. And that's exactly what we need for confidential computing. A software stack on top of what the hardware vendors are doing and on top of what the cloud vendors are doing to make it easy to use it across everything. And I guess to kind of where I think this is going, and again, to build on what Mark was saying, I think where eventually this is going is that confidential computing will just become computing. Everything is going to be running in confidential computing, and we've seen this over and over again when it comes to security, right? 10 years ago, almost nothing was running in HTTPS or in TLS. Today, any personal blog is using HTTPS. We've seen it with disk encryption, where 5 years ago, almost nobody was using it, or maybe the banks. Now you can buy a laptop without your disk being encrypted. The only place where data is not protected today in memory. That's the sort of the last place where data is not protected. But as Mark said, this is not part of every hardware that's being shipped on the server side. And I think it's going to be on the endpoint side as well. Every hardware is going to have this, and it's just going to become ubiquitous. Everything is going to be running in confidential computing. And we need to think about what that world looks like when everything is confidential computing, because we can get rid of a lot of the security stack that we have today if the data is never exposed to anyone, regardless of what level of access they have to the infrastructure.
So going back to use cases, so what about use cases that you didn't expect, or I guess you think that should have been something that we've seen by now, right? So use cases that are slightly not as obvious, maybe to this audience, that you would like to see or have already seen early signs of.
I think some of some of the use cases, like I would have thought like some of the enablement stuff would have moved a lot faster. One of the challenges, though, that I think that we face, to Mark's point, is the native services, right? If you look at cloud adoption, originally cloud companies came out with just IaaS providers, and it was made mostly development clouds. Like it was made for the developer to give you infrastructure as a service, and then we created PaaS and SaaS layers and all this kind of stuff on top. One of the challenges or use cases that I think the challenges with those use cases is we rely on databases as a service. We rely on this as a service already. So now it's like, well, how do I put that into the enclave? Right? So I think I'm tweaking your question a little bit. It's like, what's the challenge of like some of those use cases that I thought we'd be closer with, or they'd just be easier? They'd be more point and click and just go, like people to move, but they're requiring to retrofit dependent services that are there, whether it be in finance processing or healthcare processing. I thought just some of those transactional systems would have moved already, though we're seeing, as Mark said in his presentation, we do see those things, but it does require them to uplift or wait for those additional as a service models that they were just relying on or had it within their enterprise to convert. So they didn't want to do it yet.
From my perspective, I'm new to Opaque. I joined in the fall, and most of my career has been spent in business applications and enterprise software. The thing that struck me the most that was unexpected is just how fragmented and immature the market is around data and AI. I expected to see more consistency within the enterprise around the various tools they use for data and AI. It's remarkable. You go into, let's say, New York Stock Exchange, who we're working with. They have a proliferation of tools from Databricks to Snowflake to Azure data sources. They'll be using MLflow. They'll be using Databricks. They'll be using SageMaker. It's remarkable how many silos there are within a modern enterprise that's already undergone a data or AI transformation. The great thing about that for Opaque is every one of those silos has its own set of policies, and they're all incompatible with one another. So that's the use case that I've seen that's the most surprising. Was I really expected more consistency within the enterprise around like data and AI ops, which has been fantastic for us.
Well, it's not surprising to me that you're running into that.
Your old hat.
Yeah. But I think one of the use cases that surprised me, and this is a few years ago, working with an autonomous driving company, is the scenario of I want to protect the data from myself. Because people think of confidential computing as I want to protect the data from everybody else. In this case, they're collecting very sensitive data off their vehicles, and they don't want their own employees to have access to that data. And in some cases you can do processing on the edge and make sure that the license plates are blurred on before it gets up into the cloud. In other cases, you might be capturing images that actually have legal implications. And you don't want employees just to have raw access to all that video feed and maybe go and find those things and use them. And so this was them saying that data is so sensitive, I want to make sure my own employees don't have access to it. So confidential computing was a way for them to get that kind of guarantee.
What was sort of surprising to me is And I think it's part of what I think made the market, it sort of delayed the market to some extent. Is we've seen a lot of companies, especially large banks, governments, these types of organizations, healthcare organizations, that saw the value of confidential computing. They got so excited by it, and they said, "Okay, we're going to go and build directly on top of the hardware." And you don't see it in other, when people want to use virtualization, nobody's going to say, "Okay, I'm going to go build my own hypervisor for this, to leverage virtualization." They're going to use VMware, or they're going to use the hypervisor about the clouds. Or if somebody again, nobody's going to say, "Okay, I'm going to build my own CUDA, or I'm going to build my own operating system instead of what's out there." And I think that's what we've seen is a lot of organizations that try building directly on top of what the hardware exposes or what the clouds expose, and then they ran into this very, very, again, they spun up these large teams. It took them years where they were able to get very, very little done. And now what we're seeing is it's becoming very clear to these organizations that you need that software stack to enable it. You need, and again, there's a few companies in that space that make it just easy to run confidential computing on top of everything. And this was very surprising to me how much resources people were willing to invest but again, they talked to the value of confidential computing. They were willing to do that. But again, there's sort of an easy button to do that, and there's no need to rebuild an operating system or rebuild the software stack on top of confidential computing.
So I have a couple of questions left, and I'm supposed to open it up to audience questions, but we don't have a mic, so we can improvise. You can just either raise your hand or stand here, and we'll repeat your question if we need to. But so, what are the most significant challenges that you're seeing in terms of adoption, holding back adoption of confidential computing?
I think it's kind of what you touch on, which is just there's so many different. The data's everywhere, right? Especially when it comes to AI systems, it's so diverse with all of the capabilities. How do you make sure that confidential computing is on by default? I think as an industry, we've moved the needle significantly. Now we have reference models for the entire full stack now, because it's a full stack problem in order to secure it and deploy it. But that challenges of getting it so it works everywhere with your dependent services. No one just uses one app anymore. So how do you get all of that to really just get it on by default so they can just turn it on? Right? Just like disk encryption, just encrypt the volume, done.
I think from my perspective, it's awareness. I can't tell you how many times I've talked to CIOs, CTOs, or CISOs and explained what Opaque does. And they're like, "Well, how the hell do you do that?" And then it's like, "Oh, well, we're built on confidential computing." What is that? So from my perspective, it's just the awareness. People are new. It's a new concept to folks. Once they understand that it's available, it's very exciting. Like I just was talking to a CIO and a CISO yesterday, and they're like, "Wait, what's the catch? How is this possible?" And they'd never heard of confidential computing, and this was a Fortune 1000. So awareness.
So awareness, yeah.
So I'll touch on awareness and then get to one of the challenges that I see with adoption. But I think this past year, I've seen a change, and actually maybe even the past 6 months, a change in awareness. I do a lot of customer presentations in our executive briefing center, and I've been evangelizing confidential computing for many years. And most of the time, they're not aware of it, and I'm telling them about something new. Over the last 6 months now, I'm getting account teams saying, "Mark, can you come and speak to this customer? They want to know about confidential computing." So now it's inbound, which I'd never seen before. I just gave to a Fortune 10 company CEO a talk on confidential computing just Monday, 2 days ago, because I was asked specifically by the account team and the leaders at that company for that presentation. So that's a change that I'm seeing when it comes to the adoption, the awareness aspect. But on the friction part, I've talked about this. I think the friction is right now the limitations in the hardware and software that add performance overhead, don't get you to the scale, or add reliability, resiliency impact. Like I mentioned, security update for confidential computing server, you need to apply that update right away. Unfortunately, that update's going to mean you're going to take a reboot today. So for Dave, I trust Dave's working on that.
Yes.
Great. Blackwell's making big improvements there. Same thing with Intel and AMD's next generation of hardware. And that's what I'm saying is the next 2 years, those things will go away. Performance overheads will go away. Scale limitations will go away. Resilience, reliability limitations, issues will go away. The software for managing these systems is coming into view, and that's why we're at the beginning of this takeoff.
Yeah, I'd have to kind of agree with the rest of the panel. I think awareness was definitely an issue. I think it's getting much better. At least what we're seeing is essentially the same as what Mark is saying. Where we had to go out and educate in many cases, now it's not the case. We go in, people say, oh yeah, we know what confidential computing is. In some cases, again, we tried. We have a team working on this now. So I think that's a problem there used to be a big problem. It's getting much, much better, and I think it's only going to get better. And again, part of it is to thank, the people here on stage. The fact that Microsoft's talking about this, and Mark has done a lot of work there. The fact that NVIDIA is talking about this. I don't know if you saw there was an announcement by Apple saying that everything they're going to do in terms of training AI models is going to be done on top of confidential computing. Things like that really help move the needle in terms of awareness of this. Which now gets to the second problem, which is that ease of use piece. And to some extent, the way I come from security. Everything I've done in my career was around security. There are two characteristics that make a security solution ubiquitous. One is ease of use, and the other one is no or very low performance impact. If you have these two characteristics, you'd be crazy not to use it. And that's exactly where confidential computing is going. The performance impact, even right now, is relatively low. It's only going to get better over time, as we're seeing. The ease of use is where I think people kind of run into, okay, we'll try to do this, but it's so hard to build on the hardware itself that they stop. And that's, I think, why that software stack that enables this comes into play, to just make it just a no-brainer. Why wouldn't you use it for everything?
So following up on ease of use, so in every other area of tech, people talk about a skills gap. So is there a skills gap in this area, confidential computing? Especially for the audience that will watch this video on YouTube, is this an area they might potentially look at getting upskilled for? Anyone?
Yes.
Yeah, absolutely. We've had multiple companies come to Opaque that were trying to build their data and AI ops stack on confidential computing, and it was just too hard. ServiceNow is one of them. In fact, they'll, as you know, go talk to them. They'll tell you about their challenges. And they came inbound and said, wait, you do this out of the box, and it's already, you do the attestation, you do the key management, you do policy management, you have workflows, great. So skills gap absolutely is a challenge for adoption of confidential computing.
All right, so we have time for maybe one or two audience questions. Gentleman in the front.
Or faith, but maybe I'll put last. You mentioned that the change of the value created by the IT versus both. It's possible to read that drive the way it is today. Just share that. So my question is supposedly that what are the changes which can drive the day that AI the for example, the federal learning law or federal built with modern market those collaboration and bond. But we see that one are the major things that you are saying that will actually change how we do Catholic again.
So just to repeat the question, what are the major changes that will enable confidential computing and AI to basically flourish even more?
Well, I think part of it is in the answer of Anjuna and what Opaque is doing and other companies, like I mentioned, which is creating that layer on top, which makes it really easy as a turnkey solution just to take advantage of processing data confidentially and especially whether it's single party or multi-party. Especially multi-party, you get another whole world of complexity. But like we said, up leveling this to the point where somebody can basically, it's like a non-confidential workflow. They're adding some policy that might be specific to confidentiality, but that same system, whether it's running non-confidentially, you get some set of guarantees when you put that on top of confidentiality. In fact, that's the way I look at these clean rooms, is you should be able to take a non-confidential clean room and just say, I want it to be confidential, and with minimal changes to the whole workflow and the whole system. But I think that's what's going to really light this up, and we already have a lot of progress on that.
And one of the things we always like to look at is how, with a full platform, full stack, how do we help the developers focus on their unique value? So they don't have to be hardware experts. They don't have to be graphics acceleration experts. They don't have to be CC or attestation experts. It's there, it's on, and then having those management stacks on top. right? And those different partners that are out there that can do it. I think that is that acceleration. And then as those come out, your ML ops, your AI ops kind of technology stacks providers just use it. They inherit it. They just use it on how you're deploying it around the world. That is, I think, where that intersection just becomes easier and easier. The platforms are there to do it today. Just requires that skill gap or expertise across the stack that you have to learn some new capabilities. But how do we push that up so you can focus on what your unique value is that you're bringing to your customers, and we can help you just deliver that and take it and help you take advantage of the technology.
I think there's a question over here.
Hello. Well, that's really loud. I'm sorry.
Oh, we got a mic. Right on.
Yeah, great panel. I just had a question. So I'm more of a computer architect than a software guy. And so, but I wanted to get the perspective of people writing software. What do you think the next steps in enabling confidential computing are from a hardware perspective for software people? So for instance, Intel SGX seems mature in the sense that you load encrypted data, you spit out encrypted data, you can attest the code. So from an ISA standpoint, what more do you really need from a confidential computing perspective? Or is it issues such as adoption of the hardware, writing code for the hardware, or stuff beyond just make the processor run faster?
Yeah, maybe I can take it. So I think what we're seeing in confidential computing is that people are moving away from, or at least the market is moving away from solutions like SGX into solutions like TDX and SCV and confidential GPUs that look different. And a big part of it is ease of use. SGX was just, again, it provides a phenomenal security and confidentiality, but it was very difficult to use. The way I view where confidential computing fits is not in the development side, it's in the more DevOps side. Same as we deploy containers, right? We don't need to change the code or the application to be deployed in containers or to be deployed in VMs. It's part of the DevOps process and how you deploy it. This is where confidential computing should fit. You have a workload, you say, okay, I want this to run in a confidential way, and you don't have to change the code. Anytime, if you have to recompile, if you have to change the code, it's gonna be, the friction is gonna be too high. And that's why you need to do it from the outside.
I think part of it's going to be at the systems integration. So even though we're getting really good at hardware independently, their performance, like the overhead for turning it on, is going down. The crypto capabilities are there. How do you integrate, right, the Intel CPU to NVIDIA GPU? How do you make sure that you integrate and the attestations work across those different hardware? So it's that layer up that stack, and then to your point, it's the DevOps. It's the operational aspects of the systems, and then what are the standards-ish that it's based on so that you can allow the communication, so you can get a full multi-hardware set to be able to truly do at-scale applications.
So just building on what Dave said, I think that is the key thing that we're embarking on now that we're going to have TDISP, is we've been looking at, in fact, some of these pictures are put the code in, get the attestation out. When you talk about these systems down at the hardware level and CPU architecture and hardware architecture level, it's going to be, I've got 5 different accelerators in this box that have potential access to this data or can tamper with it or leak it. And now I need to have them all be confidential, and I need to have them all attesting with each other as a platform attestation for that. And they need to be able to deal with upgrades and dynamic attestations without restarting the workloads if I apply a firmware update. And in fact, this has been a mission for Azure and the other hyperscalers of pushing the hardware vendors to have zero impact firmware upgrades. Well, that in non-confidential is complicated enough. When you bring confidentiality in and say, what does that do to the confidential trust boundary and this new code that comes in, how does the application know about it and can make a determination of whether it trusts it or not according to policy? Those kinds of questions are starting to show up.
All right, so let's wrap this up very quickly. Whoever wants to take this. So let's look at this conference next year. So what do you think are the most exciting developments or breakthroughs that this audience should pay attention to looking ahead to next year's conference? So Mark has talked about the proliferation of hardware. You've talked about ease of use. Anything else that jumps out in 30 seconds?
I would say that you're going to see by next year that we'll have many more software applications running on confidential computing natively. You look around, there's a few here. Opaque, there's Fortanix, there might be a couple of others out there, but most of the players are further down the stack. Next year, you're going to see confidential native applications that are vendors here.
Mark, 20 seconds.
I think next year you're going to see cloud service offerings for AI that are confidential.
Awesome. And with that, thank you. Let's thank our panel.